want to welcome everyone again. Today is the last day of the workshop. We'll be looking at calculation of sample size using WinPepi. I believe all of us here have the WinPepi because I shared with us some times ago. And that was why I didn't bother to know, because most of the people that are here, we've attended one workshop or the other. But in fact, when we did the chi-square the first time, I was thinking that we'll use it for, I usually use it for chi-square for trend. But the subsequent one, I discovered that linear by linear in the expressor is the same thing. That was why I didn't bother the next batch to use the WinPepi. They're all the same. You use WinPepi as calculator also. It's good to maybe one of these days, maybe apart from this calculation, we may look at how do you use it to calculate, to share chi-square. After you have done on a table, you can just enter value and calculate the chi-square out. So it's a very fast way. Sometimes some of the examiners, that's what they use. When you have the table, you can just use the statistical calculator to check the chi-square. Because some people tell lie. You just put a value there, just say significant. If they enter into a hand of examiner that have time for all those things, because they just sit down and cross-check with the calculator. Where the person is telling lie, they will catch the person. And they will make up the amount to fail the person on unless the person is able to prove that it was a mistake. And when the thing is very many, you cannot prove that it's a mistake. So that is why it's good to know that, especially those who are going for exam, so that they will not do some sure and believe that they can go away with it. So we'll be looking at how we use WinPepi. I believe everybody have it installed. You have it here now. I know that Dr. Ekobo has it on his computer. Ugo, I think you have it also. I don't know, Prof, do you have it on your computer? Prof?
Yes, I have it, sir.
Yeah, okay, that's great. That's great. I think
Yes,
Dr. Balogun has it also. Because that time Dr. Balogun, yes. Yeah, you too.
I have it.
Okay, that's great. That's great. Do you have WinPepi? Don't know. Okay. I know Joshua.
Good afternoon. Good evening, sir.
Good day. Do you have WinPepi on your laptop?
Good evening, sir.
Good evening. It seems that you are feeding your baby. Do you have WinPepi on your laptop? You should have it now for that first time. I'm Ugo.
Sorry, sir. I'm with my baby. I have it on my small laptop.
Okay, that's great. No problem. Very shaker. Okay, no problem. General Afin. Now, how about you? Just show your face. How now? Okay. How now, General Afin? Okay. Maybe your volume is somehow. Okay, let's quickly go to the business. So we know that we have talked about, we are not going to be wasting time on the formulas because we have talked extensively about them in the lectures, in the series of lectures. And I keep on saying it, all the people that are here, everybody, I want everybody to subscribe. I can tell you categorically that I even value you subscribing, that you paying for this one. I can even allow you to come and attend this workshop free. But I want everybody to subscribe. And the reason is very simple. The subscription is more like win-win situation in the sense that it's just a token. And once you subscribe, you use it. In the process of listening, using it, some people that may need it may stagger at sit and I don't know this one exists. And because it's very cheap, people can easily subscribe. So it's more like networking to me. So I value everybody that is part of what we are doing here to subscribe. I don't mind you coming for the workshop without pay, but I want you to subscribe everybody to subscribe for that, because that's the only way you can get the link to other people. And if you are benefited, you please let other people, because people are fond of, when they benefit, they will be hiding it. At postgraduate level, some people still behave like that. If they get to know something, or maybe they get a source, have a source where they get some secrets to what they are doing, they will hide it. So be shining among the peers or the mates. Yeah, you'll be moving stuff, but they will be hiding it instead of you to let other people benefit. Because the person that is bringing it out also, if you want to hide it, you will hide it better. You want everybody. If you don't do the right thing, let everybody benefit. So that is why I want you to subscribe. So in the previous, if somebody, if you watch it now, and somebody is asking, I did not discover that we said something like that in that video. Better go and watch this video, subscribe. So that is the logic behind me saying everybody must should subscribe to it, because a lot of things we talk here, if actually people find time to watch the video, you discover that we have discussed all those rudimentary things. We talk about degree of freedom, we keep on saying it, but we have discussed them. So all those parameter statistics, all the basic concepts, all those things have been trashed out in the previous video, in lecture. So I want everybody to subscribe to the lecture, the material. So now let's start with descriptive. We said that for descriptive study is one group. What makes a study descriptive is one group, no comparison group. That's all. No comparison group. You are not studying two. The group we are talking here is not actually, may not necessarily mean group of separate group of what do I call it? Separate group of subject. No, it may be one group of subject, but you have collected your data more than one time. You have two set of or three set of data, more than one set of data from the same group or from different group. Well, once you have more than one set of data, it's not descriptive, it's analytical. And if it's only one set of data, it's descriptive. And by nature, I've said it that experimental design is analytical, it's not descriptive. There's no experimental design that is descriptive. But if it is one group, that shows that you have done the group control for itself. You do post, pre and post. That is, you carry out your observation more than once. So there's no experimental design that you carry out observation once from a group. If you carry out observation once, that shows that you have more than one group. So if it is one group, you must carry it out more than once. So experimental design by nature is analytical. So for the descriptive one group now, the way you approach your sample size depends on whether the outcome measure, the variable of interest, is categorical or quantitative. If it is categorical, in the previous literature, you'll be seeing something like prevalence, percentage, that is in percentage. That this is the prevalence of this is the proportion of this. That is categorical. But when you cannot see is what I see is this is the mean and standard deviation. That shows that the outcome measure you are looking at is quantitative. Though there are some outcome measure that are quantitative naturally, but by the having cutoff to become categorical. Like hemoglobin concentration is quantitative measure, but by the time you have a cutoff, hemoglobin concentration less than certain value is anemia. So you are now talking about prevalence of anemia based on that. So when you are doing that type of study, you have to now make up your mind. What are you going for? If your study is prevalence of anemia, that shows that your time is okay. After you have done the hemoglobin concentration, you have a cutoff where you say all these people are anemic or not. So in that case, you assume that you are using proportion. But most of the time, that will only happen because hardly will you see people, or it's very rare for people to use the mean, the other formula, but it's being used, not that you cannot use it. But the one that is proportion is common because even those things that are naturally quantitative, people get a cutoff and turn into categorical, like prevalence of hypertension also, diabetic, no prevalence of diabetic. obesity. All those, the underlying measures are quantitative. The people just have a cutoff. But most of the time, the European or the American, they like to study a particular variable in its natural state. Because you know that when you categorize, you lose some value, you lose some things. So, like, they would rather, to me, is even better to say, okay, hemoglobin concentration. Rather than say, what is the average hemoglobin concentration? Rather than say, what is the prevalence of anemia? Though, that prevalence of anemia is just a prevalence of something. It's a way clinician judge and administer treatment. Anybody that has, just like diabetic. Somebody that has blood sugar 126 is diabetic, 125 is not diabetic. So, you see, what is the difference between 126 and 125? So, you see, it's just for convenience, just have their cutoff and begin to, administer your treatment. But sometimes if you don't want, so when you are now trying to look at the relationship between that variable and the factors, by having that cutoff, you have lost some power. You have lost some things. That's what people don't know. If you study that particular attribute in this natural state, then try to look at how the factors affect that attribute is better. Like for the diabetics now, if you look at if you want to run regression, if you run linear regression to see how factors relate to blood sugar, it's better than having a cutoff as a diabetic, not diabetic. That is commoner in clinical journal because people, that is why they prefer you see logistic regression is commoner in clinical journal than linear regression. So let us just proceed. What we do now, we start with descriptive, then proportion, then we talk about, we also talk about adjustment for populations, how all of those will be considered, and also try to adjust for non-response or attrition. All those things will be considered. Let's look at the first scenario here. This is a case where you want to know the prevalence of an attribute. And this scenario is very common in the sense that sometimes you search your literature, especially if that particular thing you are studying, attribute you are studying is rare, maybe not much study has been done about it. You may search literature, you may not easily see previous work, what is the prevalence. And I've discussed it before. In that case, you can assume 50%. That's what called maximum variability. You don't lose anything apart from the money you spend in assuming maximum variability. In fact, it will have been the best. Assuming maximum variability will have been the best for any time you have studied prevalence of something. But because of money, because of resources, because why it is the best, in fact, it's the best because it's the one that assumes the maximum. So whether the prevalence is high or low, what you're going to study, it will capture it the way it is. But if you search literature and say, oh, this is the prevalence, are you sure? Even this the one you quoted, are you sure? But the fact that somebody published something doesn't mean that he has probably the result is okay. People just publish, sometimes they just publish for publishing's sake, and people reference, this is the prevalence, the work done, so and so. But if the work was poorly done, that estimate may be far from reality. And when you are now basing your, okay, the prevalence was 80%, and I'm basing your this thing on that, you now calculate. If actually the prevalence is far from that 80, maybe it's something like 60, you yourself, you get wrong results. Because when you now calculate sample size based on that 80% or 90%, and in fact, two things will happen. You either overestimate or underestimate. You may discover that, what you have done is, it's like the person is consistent with the one you use to calculate your sample size, or it's like opposite, maybe far apart. So that is why it's even better if you don't even see the literature, you now say, okay, let's use 50-50. In that case, it will capture it the way it is. Okay, let's look at this situation now. If we assume, you know the formula is what I showed you for, look at it. N is equal to Z for descriptive study, when you're talking of proportion. N is equal to Z squared PQ over D squared. Minimum sample size is the N. I'm supposed to remove this for each group this way. Then, let me even remove it now, because sometimes when I'm presenting, I just discover something, I say I will remove it, I will not remember. Just minimum sample size. Yeah. Now, yes, minimum sample size. Then Z is the standard normal deviation that corresponds to the level of significance. So if our level of significance, you have to make up your mind on what level of significance you use. If you use 5%, that shows that you are dealing with 95% confidence level. Your Z will be 1.96. And if you now say, okay, D, of course, your Q will be 1 minus P, or 100 minus P. So your D is the level of precision. You set as most of the time also at 0.055%. That 5%, 0.05 D is different from 5% level of significance. It's quite different. So look at it. It will always give you, when you assume maximum variability like this, if it is 50-50, it will give you 384.16. That is it. Every other thing, if you have used 2T, level of significance 0.052 T, and you have chosen your level of precision to be 0.05, 5% also. So you are seeing 5%. This 50% maximum variability is the prevalence of the active. You assume that it's like tossing a die. You toss a die, 50% is AF, 50% we take. For you to be able to do that, together with this thing, you have to toast the die many times before you can get 50-50. And that is why, so if you toast it, it gives you maximum sample size. And that maximum sample size is the one that gives you the best. Now, don't let us overflow that. So, look at the scenario here. Same thing, yeah? 0.05, just put it gives you 384.16. Now, in this, if, let's say you are studying the community now, that will be the sample size. But if in the situation, look at it, N is 900. That is, let's assume that maybe you are studying facility and the population you are studying is limited, less than 10,000. In that case, your N, let's say, assume is 900. When you adjust for it in the other formula, it will come down to 269.25, which is like 270. So let's see the way you use WinPepi to do it. Let's see. Somebody's chatting. Okay, go.
Yes, Dr. Dolapo.
Yes, sir.
I don't know whether I can ask question at this point.
You can ask question.
Yes.
Go on, sir.
I've actually had to try out a sample size calculation using different precision level.
Yes.
And
yeah.
Yes, in the source of literature that I read through, they say when you have prevalence between, let's say, 30 or 90%, that if you still quote the value of 0.5, you may see 30 to, I'm talking about proportion now, from a previous study you are quoting, is if it's between like 30 and 90%, that most times when you use 0.5, things will be in order, but you should actually do that with a precision level of 5%. So what I see some people do in order to minimize the sample size, because if you keep varying the precision from 5% to 6 to 7 to 8, what you are going to get is going to, yes, I can see that from 300 and something, when you use it's from 384 that you got with 0.5 with 5% precision. Now let's say you take that precision to like 8%, you are going to get something like 100 or 90 something, which is a very convenient way of saying that is the sample size. So the question I'm asking is that, is it advisable to adjust to move away, let's say from 5% to something like 6 or 7%? Sometimes if you are doing a kind of study that you are not too sure, you will get an adequate sample.
Where?
I'm talking about the denomination now for proportion.
I know you're talking about. I know that you're talking about it. You know that, let me just tell you the truth about that. But if you do that, nobody will like to take it from you. You believe that any precision level that is greater than that. You know, when you increase to 7%, it's less precise. You know that. You know that it's less precise.
Yes.
And it is when you want it to be more precise, more accurate, you reduce the value to 4%, 3%, 2%. It will jack up the sample size. So if you want to manipulate anything, you want your sample, it's not that one you use. Because if you want, you cannot increase it beyond 5, but you can reduce it to 4. It means that it's more precise. It more sense. So we usually use it when you want to do, maybe you want to do study for some organization. Like maybe you want to do something for organization where there's money. You can sample 2,000, 3,000 people. You just want to justify. You already make up. Let me tell you, even the organization, they've already made up their mind what they can fund. So it's just to academic purpose, just to justify, because of people just raise the ugly mouth. Say, how do you come about the sample size? So to justify that, to manipulate, by the time you shift from that precision to 0.4, it will jack up the sample size. You can manipulate that one. So there's nothing that fits you at 5. But people will not take anything beyond more than 5. But they will take anything below 5 is an addition. It's a plus. The only thing is the more resources will be expended. So that's just it. So that thing you say about between 90, because I wanted to point out something you said. You said you read in literature that between 19 and 30.
No, it was just a general statement.
What is it?
It was just a general statement that if you are doing a study and you expect the proportion of what you are going to get to be between 30 and 90, maybe from previous studies, 2 or 3 studies, then you can stay with the precision of, you can stay with the prevalence of 5. Oh, sorry, 50%, sorry. That's 0.5. I'm talking about the
in the literature, what did you get in the literature?
No, varying numbers. Some say 30.9, some say 60.
I'm telling you, you cannot, if you have a value in the literature, you don't have justification to use 50%. The maximum variability is assumed when there's no literature. You understand me now? You use it when only use it when there's no literature. You want to be on the safer side, because if there's no literature to back it up, if in the real life the prevalence is at the extreme, like 90 or 30 or 20 or 80, all those one, you expect smaller sample size compared when it's close to the middle. No, I've already demonstrated that. When the prevalence is close to 50%, you will require the larger sample size to capture. So if you don't have literature to back it up, and you just go and do anything, maybe you just put any value like a 30, you get certain previous sample size, which we assume that is assuming that the prevalence is around that 30 or 70. You know, 30 and 70 is the same thing. 20 and 80 are the same. 40 and 60 are the same. They are complementary. 10 and 90 are the same. So when you get any of those values, it gives you the same value. Because it's the same. If you say the prevalence of anemia is 10%, and the prevalence of not having anemia is 90%. So either you are studying anemia, you are not,
Okay.
or you are studying people without anemia, you are studying the same thing. Yes, and the other somebody that say you are
Okay.
studying the prevalence of women. So if you are studying prevalence, we are also studying the prevalence of men. Yes, I mean, because it's complementary. If you are not a man, you are a woman. If you say, oh, men, women constitute 30% of those people, automatically, of course, what you are saying that men are 70%. And you see why you see the logic now. So you see, it's just like if you remember
Yeah.
further math or mathematics of further math, you know that sine 30 is cos 60, 60 because both of them are complementary, add up to 90. You know, all those logic like that, it's the same thing. So when you use something like that 50, you are afraid, you don't want a situation where if you go and use anything other than that, and in real life, the prevalence around that 50, you will not be able to get the real picture. You get wrong result. So if you use 50, whether the prevalence around that 50 or the prevalence is less than that, you get the true picture. So, but if you don't use the 50, if paraventure, the prevalence around that 50, you will not get it. So that is why when there's no literature to back it up, you assume maximum variability. Sometimes also if you want, because if you want to do analysis that require multiple regression, you need a lot of samples, you need number, big number, to find the differences out. So many people want big number, especially for survey. No, for survey when people are there in the community. So why are you minimizing? The more you get, the more. It's only that it will cost you more, but the more the power of the study will be. So people now look for way. Okay, just use 50. If you cannot manipulate through that one, you will now manipulate through that denominator precision. You lower it. Once you lower it, you jack it up. So that's how to do it. That thing, I thought maybe because when you were saying between 90 and this thing, I thought you were good because something came to my mind. You know that if
Sorry.
it's
Maybe,
yes,
okay.
if the
Maybe I
if your
was
sample
wrong.
size is very small also, if your what did you say?
Yeah.
Yes.
I thought it was correct. It was 30 and 70, not 30.
Okay,
not 30
no problem.
and 90.
Okay, whichever way, between 70 and half. But the issue there is if it's beyond that, that is, if it is around 20 or 18, that's what because it's giving you lower sample size. Somewhere, if the sample is very small, you may even detect the prevalence of that thing, but you won't be able to imagine now if the prevalence of something is around 90 or 10. If you get 100 people, around 10 of them will have the attributes. And 10 and 90, if you are trying to look for the factor, the most statistic will not, it will not give you anything reasonable. 10 on one side, 90 on you looking at factor that is responsible. You'll be getting results that are not chi-square, not valid, all those stuff. So people, if you have higher sample size, so that is why maybe those people say that thing. So if you now adjust the denominator, reduce it, it will jack up the sample size. Even though the prevalence you are putting is around 19, which is supposed to give you small size better, you want to jack up the sample size. Because it's somehow, if the attribute you are studying is extremely rare, it's extremely rare. If it's 0. So, you now do it. What will it give you? It will give you one small sample size. So at the end of the day, even among the people you get, you may not even see people that have the attribute. In that case, you need to look for a factor to jack it up. And the best way to manipulate is that denominator. When you reduce the denominator, it jack up the sample size so that you'll be able to detect because there are some attributes that are very rare. Like if you say you're looking for megaloblastic in the population or folate deficiency in the general population. So you may sample 200 people, you may not get one. So in that case, the prevalence is 0 point something %. By the time you calculate, give you small value. So you want to jack it up. In that case, you use the denominator to increase the sample size so that you can be able to. In that one, it's not that you are dictating it's not for you to, it doesn't change the prevalence. That one does not, you are not trying to increase the prevalence. Well, the prevalence there is only that the number you have got is too small to even get them. So in that case, you jack the sample size, or it does not increase this prevalence. So at the end of it, if this prevalence is around 0.05 or that 5% or 0.005, 0.5%. So you may have to have, if you have to get 2,000 people, you even detect some people that have 4,000 to now have few people that even have the attribute. So it does not change the prevalence, but it's helping you to at least detect those people. Now, somebody is sending, Lisa, can you explain the 0.5 for maximum variability? Lisa, you mentioned it's better to study a variable in its natural state. What do you mean? Did I say a variable in its natural state? I can't remember that one. Maybe you should throw like that. I can explain the 0.05.
You said diabetes. You were saying diabetes.
Okay, that one I said that it's better you study blood sugar. If I want to know what are the factors that raise blood sugar, yes, I'm not. So I would rather, if I want to do regression, I would rather do regression, linear regression, without blood sugar, rather than having the cutoff where I say diabetes.
Why?
Because the reason is that some people that have 126, you say they are diabetic. You have put them on that side of diabetic. The people that have 125 is not diabetic. And what is the difference between some that have 124, 125, and 126 and 127? The 126 and 127, they are on the other side. They are diabetic. While the other one are not diabetic. Can you see? So it doesn't bring, you lose power with that.
Okay.
Unfortunately, that is what we clinicians do, because it is easier for them to say, oh, let me know those people that I want to treat and leave those people who don't want to treat. You have a cutoff. Not that it doesn't work, but all those people at the borderline, it doesn't work for them. It's just like our p-value, something like 0.055. You see, it's not significant. 0.049 is significant. What is the difference? The difference is 0.006. Can you see now? It's the difference between the two. This one is significant, this is not significant. It's the same thing. So it's just like people that want to get admission. When they say somebody that score, maybe you want to examine somebody that score 260, enter. 259, they say it didn't enter. You and I say, can you imagine? 259. Somebody didn't enter. Only one mark. This cutoff. This cutoff is 260. But you don't know that people that score that 260, they are plenty. The people that now score that 259, there are plenty. They may even more than 100 that score the same mark. And there's no space for all of them. So sometimes the borderline, so it affects your judgment. So that is the real. And to be sincere with you, just like medical school, somebody says someone just scored 50, it's pass. Someone that scored, when they calculate, they say 49.9. You see the specific. The specific. So we begin to imagine. So sometimes the judgment is just like that. So that is why it makes more sense to use the natural value to run the analysis. Yes, go on.
Now, I was trying to understand the logic behind, and when you used to say that, when you're going to be doing factors affecting something, why you have to jack up the sample. I've always wanted to understand the logic behind it.
Okay.
Why?
If the prevalence of something maybe is around 5%. Naturally, the prevalence of the attribute is 5%. And you want to know the factor that is responsible. By the time you calculate, with that 5%, if you give you small value, maybe about 110. Let's say your sample size is 110. Or 100 self, or around 90 something. So in that case, out of the 110, maybe you may, if the prevalence is actually 5, maybe 5 or 6 people that have the attribute. So when you are running the analysis, because the analysis also is it's permutation, it's an arrangement now. You list 5 people that have the attribute against 90 some people that don't have the attribute. you are looking at the factor. On the side of the 90-something, you got to see variability in different things. Age, sex, all those stuff, marital status. But on the 5, there is few. So you cannot, because it's arrangement. So you discover that on the side of those attributes, there are too few. You cannot get any reason. But if the sample size is around 400, if the prevalence is 5%, you can have about 20 or 25. Or if the sample size is very large, you can have up to 30 on that side. So it allows for the variability of those attributes. So really know, because the factor you are looking for, it is when it's more common. The proportion of the people that have that thing is higher among the people that have the outcome event. That's is responsible. For you to know the factor responsible, if you want to know sex is responsible, this one is commoner enough among female. That shows that more when you look at the attribute you are mentioning, let's say anemia or HIV positivity, you'll be able to see that more on that side, more of the women, the proportion that have the HIV are higher than the, so it's arrangement. But if the people that have the something that are very, one side is very small, you won't be able to bring it in. And I've already told you, whenever the sample size is very small, the standard error is large. When you increase the standard error and you increase the sample size, the standard error becomes small. So the side that is bigger has more precision than the other side. So that is why it's good. That is why descriptive study only test create hypothesis. It cannot, if you do descriptive study and you find out that women, this one are more likely to this one. It's just creating hypothesis. You need to validate it with analytical study, just like the study you did now. Maybe somebody has done the script study. When they did the script study, they discovered one group study. They saw that the private people, the children, the students in private university, they are more likely to take drug more than the public do just through extrapolation. But it's a crude. You cannot rely on that, because when they are running the cross-tabulation, you discover that on the side of the people that take drug, they are small. On the side of you that don't take drug, there are plenty. Yes, I mean, somehow, whatever, if you are trying to see the factors responsible, is more robust on the bigger side than the other side. So whatever we find is just a pointer. So for you to be able to say yes, you now have to now do analytical study, the one you now did. You now sample the same number of private and sample the same number of public, and now see the attribute if it's the same or different. Can you see? So you are now proving that is what we call deductive inference. Why the other one is inductive inference? The other one that generates hypothesis is induction. Why this one is deduction? So let's continue.
Deductive.
So let's just continue. Now, let's just go back to what we're doing. I will try to share this. Look at you can see the WinPepi now. Can you see it? Can somebody see it?
Yes, sir. Yes, sir.
So
yes,
now,
sir.
for descriptive study, when you click on it, give you this. For descriptive study, you go to describe. Can you see? Describe descriptive epidemiology. You click on this. Oh, I will share again, because when you click on anything there, it will stop sharing it. But can you see now? When you click on it, it gives you this. You now say you see estimate sample size. Can you see K? Under K, you see sample size estimate. You now click on it. Immediately you click on it, you can see it. It gives you this and give you option: estimating a proportion, estimating prevalence rate, estimating a mean, finding a given number of cases. So the two we are calling the common one we ought to look at is estimating proportion and mean. Estimating prevalence rate actually is the proportion over time. So most of the time, when you are calculating all those infant mortalities, those things you measure over time for the population. That's where you do that one. And most of the time, when you're doing prevalence, So is the proportion and the mean. So let's look at, you click on that, immediately you click on that population, studying a proportion. Look at what it gives you. It says simple random sample, certified random cluster sample. You remember this cluster sample? We talk about it in, when you talk about design effects. If you
Yes,
click
sir.
on it now, it will be different. If you click on it now, we will ask for some homogeneity, interclass correlation, whatever.
Wow.
Yes, but those from most of the time. Since it's simple, you just click up by
So can
default.
you see, let me see, do stratified, see what stratified will bring out.
You have this thing, or you can go and do it.
Okay.
You want to give
Okay.
you for you to give the proportion of each stratification. Before you can, yes, in the population.
Wow.
So all this thing. Just when you get home, go through,
Okay.
go
Okay,
through
sir.
yourself. When you go through one by one, you be clicking on, you see, you study it very well. That's just it. So you will see by default confidence level 95. That was already told you that your level of significance is 0.05. Can you see now? Unless if it's going to be 0.01, you can change to 99%. But because that's what you commonly use, 95% confidence level, you just leave it like that. Assume different. It's an estimate. That D we are talking of, that D, the 0.05, the one Dr. Balogun was talking of, that is what you type there. The level of precision, 0.05.
So you have two dots there. Okay.
Then I remove it. Then assume proportion. The proportion you assume, that is. So
Is
let's say
that
we
the
assume the
prevalence?
maximum variability. That is the
Okay.
proportion you are talking about. Do you get
Yes,
it?
sir. Yes,
You
sir.
now say, okay, if you look at, we are coming back to this population side. This one now, you just assume that, okay, is a infinite population,
Okay.
big population. Those are things that is in the formula. The 95
Yes.
is the one that
True.
stands for the Z square. In Z is Z, which is in 1.96, you put the formula. But you may not see the 1.96 there. They have already inputted it in the program. So when it's known in your formula, what stands for the 1.96 and the 0.5 level of significance is the 95%. Or what stands for 0.05 level of significance and 95% is the 1.96. Because
Okay.
5% and level of confidence equal 100. 5% correspond to 95% confidence level. And the standard normal deviation is 1.96. If that one is relevant when you are using hand to calculate. They already told you, though they already put in the formula here, but this is 95%. This is the level of precision, and this is the proportion. So you click on it, you will see. Can you see? What does it give you? You can look at it. 385, can you see?
385, wow.
Which is 384.16. You see there, just approximate. Can you see?
Yeah.
So look at it. That's the sample size that's giving you. So you now, if we want to go back now, maybe that population you are studying is not infinite, it's a finite population. Let's assume it's 90. When can you see this? I'm showing. Let's assume it's 90 now. That shows that if you adjust for this formula, it gives you 269. Let's go back there.
Okay.
Sorry, I'm in a lecture, please talk better. Yes. I'm in a lecture. We'll talk later. Let me put my distance. Hello? Yes. Let's just continue. Let me put my this on silent. Yes. Dr. Odusholu, where is your friend presenting?
Tomorrow, sir.
Tomorrow, sir.
They said tomorrow. I thought you said Tuesday.
No, it's tomorrow.
He has been disturbing
So
me.
you see the one calling you.
He's the one calling me.
He's the one calling you.
Yes, now he's.
She needs to find information for all this, your crew, scowaris and
Yes.
stuff.
It's not that one. The lady is a pester. So they said Tuesday before. I don't know why they now change it to tomorrow. Because I have other things I'm doing.
Because there are 4 people. There are 4 people that are presenting their book.
I help me on that part. Oh, the AC.
Sir, there's this thing I want to read. What Dr. Baloko said previously. I can see it on that WinPepi. He said that if the observed proportion is between about 0.3 and 0.7, what does that one mean? On that WinPepi sample size that we calculated.
You're saying checking now. I myself.
What does it mean?
I don't know. I'm not the one that did the WinPepi. You can check it.
So I was like, what you said before about 0.3 and 0.7. Is it that what you saying?
I've already told you the reason. So when you had the question, I've already told you. The reason is that they want a situation where you can see jack up the you can. So if for you to be able to have enough sample size, it's better you use precision less than 5. If you use the precision less than 5, it will jack up. It will be more precise. Instead of using 5%, you can now use something like 4%, so that you can have a good sample size. Okay, let's what I was even trying to, yes. Now, if you go back now, let's say, sorry, I'm supposed to, I will just say repeat. And that thing, we put 0.05 here, and 0.5 here. And I say our population is 900 rather. Can you see? If you now run it, you will see. Can you see? 270, which is 269.25. Can you see? Which is the 250. So yes, adjusted for that population. Can you see now? Is it clear?
Yes,
sir. Now another thing you can do. Yes, sir. Go on, sir.
Sorry, I'm sorry.
I'm listening.
Now, for purpose of what studies in clinical settings, if you are going to be, on what situations do you assume that your population is 900? Is it just because if you think you are going to spend a lot of money looking for 384 samples, and I can just write 900 cases is expected, maybe over the period of time that I'll be carrying all these studies, and I'll decide to do that and get a sample size of 279, that would be cool. How do you argue that before, if I have to be an examiner and somebody does this, on what ground would that patient, would that candidate really tell me this is the reason? I would say, okay, I understand, I pardon. Because this looks like as if it's a way to scale down the figure rather than.
We can't study all the population.
Okay, let me answer.
It's a finite population.
Just like what you said.
No, now, in what situations do you really define that finite? Is it that the common problems were, let's say somebody is doing
less than 10,000
on malaria, for instance, compared to somebody studying maybe appendicitis, you know the prevalence, they are not the same. Definitely, if I were to study malaria, I would say, okay, in Lagos, I will expect a very large population. But let's say I'm studying appendicitis in Idiaraba, for instance, the population will be far smaller than that.
You cannot relate categorically
that I'm studying.
Okay,
why 900?
It's just an example now. Let me first of all start with the last statement you said. If something is common and something is rare, they may have the same sample size. Imagine if it's something that is as high as 60% and something that is 40%. But both of them from the formula, they have the same sample size. If something is very common, 80%, and something is rare, 20%, they have the same sample size. If something is very extremely common, 90%, and something that is rare, 10%, they have the same sample size. They may have the same, can you see? Now, the 900 is not a magic. In some situation, you calculate your sample size with this first formula, you discover that the study population you are able that are available to you is not even up to that sample size. Yes, I'm not. Because that one is assumed, that first calculation is assumed that you are studying community where infinite population, where you have a lot of people, more than 10,000, they are there, 10,000 or more. But in a situation where you are studying in facility, like you want to study even over 6 months, the people that come in that cut in your study population, like now if you are studying people diabetic now, it's only the people that your study population is the people that come to diabetic clinic. So even for 6 months, you may not have 10,000 coming to diabetic clinic. So you get it now. So you have a population, finite population. So it depends on the clinic now. And that one actually does not depend on the prevalence as you are talking. It doesn't have anything to do with the prevalence of that thing, but it has something to do with the population you want to study. You understand me now? Like, you are a surgeon now. You want to study some cases that come to your clinic. So what determines that is how many of those people that come attend your clinic. So that will be your study population over a period of time. If you want to study over 3 months, you get it from a previous record, 1 year data, that is population. You now divide it to 4 to be able to have, it's just a still rough estimate because the people, the way they come to the clinic may not be the same throughout the year. It may vary. And what happened last year may not repeat itself this year for some reason. And you just assume that what happened last year will keep on repeating itself, and you just assume it's just a rough estimate, just for you to have an idea of how many people will come of those population you go to that will appear to you within that time frame you want to do the study. We now use to adjust for your formula. Otherwise, in some situation, even the population may be less than your sample size may be more than those people that are in that category. So I think that will answer your question now.
I have a question.
Okay, sir.
Can you hear
me?
Can you hear me?
I can hear you.
Hello.
I can hear you.
Why did they make it? Why did they make it optional? Because the first one, they didn't use that optional population, this thing. So is it that if you like,
why it is optional? You will see it there now. Let me click on this thing.
As if you like,
you don't like. Why it is optional is that when you are dealing with finite population, you use the first one. That's why it's optional. It's not compulsory. But if you are not dealing, if you are dealing with infinite population, big population, you just stop at the first one without clicking on the population. But if the population is in the facility, you have so, and of course now, even when the population is in the facility, you still have to calculate that first one before. So that is in addition. That's why it's optional. When you say something is optional, it means that it's for those people that need
understood. I've understood.
Yeah.
I've understood.
Dr. Balogun is that we are still having some issue there.
I think the key part.
Okay. Sorry, Doctor.
No, you can continue, sir. No, okay.
Yes. My optional population is 300. Can we just put like 300 cases and see what the sample size would be like?
Yes, you can put now.
That 900.
Yes, now. 200 cases.
200
population.
Sorry, go answer your question. Sorry.
Yes. The sample size is 134 now.
Now you are talking. This is practical.
Yes, I was saying that it's correct. I was just trying to add to what Dr. Dlako was saying, that the cutoff is usually that 10,000. Once it is 10,000 and below, it is a finite population. So most times, any community-based study, it would always be infinite because there's more than enough people. But if you are studying, let's say, for example, you're looking at a particular facility, or you're trying to study, let's say, children attending crèche in, let's say, university, you will know that, like for he has said, like all the people that will probably come to that place, if you sum them up, they won't even be up to 100. Or even if I want to say Dr. Dusholu study, I don't know if the support groups in the whole of Lagos, I know you did Lagos State, they were up to 10,000, but if they were not up to 10,000. Okay, they are more than
the PLHIV in Lagos State, they are over 200 now.
That's 200,000. Okay,
they are more than that.
So I think the whole idea, like you said, it is based on the population. It's based on the population, your target population. Thank you, sir.
I think we can
so
proceed.
10,000 is the benchmark.
Can we proceed?
Yes, sir.
Okay. Now, I see some scenario I want us to look at. Now, let's assume that the same thing. The population is 475, and you also want to adjust for 10% or any percent attrition or non-response. So you know the non-response, the way you do it, if you are calculated, look at this one, 213 divided by 1 minus the attrition. If attrition is 10, you now divided by 0.9 or 100 over 90. Can you see? So it will now give you 237. I do remember the formula I discussed it. Was it yesterday or when did I discuss the formula? So let's go back. Can you see it now? I shared the WinPepi here. Now let's go back now. Repeat. So in this case now, the population is 475, right? Yes. The population is 475. And look at it here.
So what population is this?
No, the female population is just look at it now on the background.
Okay, it's just an hypothetical. Okay.
It will give you, the answer should give you 213. Look at it. Let me follow that one. Can you see 213? Can you see? That's what we calculated here. Now, see, you want to now calculate, and that one is optional also. You want to allow for loss, for either attrition or no response. So your percentage, there's a 10%, you write it, look at it, they put percentage, it's not 0.1, you write in percentage, 10. Can you see 10 now? So you write the percentage attrition or no response. So you now know. You will see, look at all the 237, that's what you get here by dividing by 0.9. That is dividing by 1 minus that attrition rate. It gives you 273.
I noticed something with this particular. I noticed something with this software. Did you notice how it has stratified, cluster, and simple random? But it doesn't account for the multi-stage. Even though yes, we say multi-stages, or you still do simple random, but you know that it's not exactly the same. It's actually doing simple random. So it's like the very if we had to like look at it objectively, the variability would be more. That is if you have to compare the simple random method to the multi-stage, because the multi-stage will probably be more diluted because you've had to go through those stages, as opposed to if you had to select those individuals. That is, do simple random by selecting individually.
But some people are
in fact, I read something.
That what?
No, I even read something. In fact, I read something. I didn't even know that they had what they call. There's something called like that design effect you were talking about. Even apart from clusters, some clusters, but I found out that they even have for the respondent driven, the one that is used for drug, that's for people that have to reach populations. Even for multi-stage, because so the book, one very old book, 1980s. I just stumbled upon it in the internet. I Skinner. She was not explaining how, because the those stages dilute the this thing. So sometimes it's still advised that you can even use a design effect or those. As I just wanted to add here. This is a workshop, so I just went to read up
Yes,
on what he said.
it is two ways. Yes, they usually say that design effect comes in when you are not going to use simple random sampling. But I see some argument also that if you segmentation very well,
Yeah.
that sometimes even the stratified one may be more accurate than simple random sampling. The reason being that, imagine that in university you want to study and you want everybody in the university, you want to study everybody in the university. If you decide you calculate your samples, if you don't stratify and say that, okay, based on the number of the student in each level, you want to allocate proportion so that you sample each level separately. What will happen if you just do simple random sampling? Maybe just get to maybe one multi-purpose hall, just be all their hall. You just begin to. You may discover that someone may be treated to one side, how you gather your data. You may discover that someone, even though you use simple random sampling, one level may predominate than the other level. Can you see now? So in that case, it has actually affected even the simple random sampling. The simple random sampling does not actually mean that it's going to be 100% representative. The only thing about simple random sampling is everybody has equal chance of being chosen. But somehow also with simple random sampling, you can still be treated to one side. What it just means that when you talk about randomization in experimental research, it doesn't really mean that the control is not different from the experimental side. It may be different, but whatever difference is by chance. Not that somebody do it purposefully. You understand me? Like, just by chance. Analyze, you may do your randomization. By the time you compare the two, you may discover that one attribute is treated to one side than the other one. But if you do your randomization, that particular thing is just by chance occurrence. It's not you that cause it. Yes, and that is why in experimental also, people say that the one that does not use control is that use the subject that say they are control for themselves is more superior. That was the issue Dr. Balogun was
because the variability will not be so much.
Exactly, because it's the same set of people you do before and after. Unlike the one either you imagine there's no way. In either you do randomization, there's no way the control and experimental can be the same. So I just laugh at people when they are presenting. Say, can you see that? At baseline, can you see that your control? Whatever you do, and it makes people to be changing result. That your friend now, I discover is already changing result. He's already changing result from data she enter. There's no way to catch them. And by the time he has done experimental design, now get distinction, and now no nothing. So that's the type of place we find ourselves. That's the type of country we find ourselves. So just be deceiving themselves.
No,
wow.
Okay.
Thank you, sir.
Because let me tell you something. Let me give you this. All the people from the time I was resident, all the experimental researchers have already analyzed for people. Now at the till now, all of them change figure. I got it. Because they know that if you don't do it, people will frown at it. Instead of you to leave it, that means if you do study, you didn't find a difference. That is a finding. Your seminar. Of course, if you know that you are going to find a difference, then if you are sure you're going to find, why you don't to do the study then? You already know that you're going to find a difference. But because you don't know, that difference, so a study must not give you a difference. And you can do a study very well, it may not give difference. That's what you want to detect. But that's that, can you see? That shows that all your effort is wasted. So what you're telling on all your effort. So that the effort will not be wasted. We adjust it and tell her. And that's education has improved this. Who are they deceiving? Nonsense. And that is why this release said that there are three kinds of lies. Lie, damn lies, and statistics. A lot of publications.
Damn lies and statistics.
Yeah, a lot of publications that lie.
Say it again. Damn lies, statistics that I want.
Lies, damn lies, and statistics.
Those are the three kinds of
Okay,
lies.
all right. Thank you.
Okay. Okay. I think we'll proceed. Yes. Let's look at the next one. So I think look at just to what Dr. Balogun was saying. What's that? What is that? Any question? Okay. Look at this one now. The prevalence, the D is 0.02, is small. The effect, look at it at Jacob sample size, yes?
Yes, I wanted to even mention something. There's something, okay. There's something Dr. Balogun was saying that I also wanted to mention. You know, it depends. Another thing, your precision sometimes can be 0.01, depending on the type of study you're doing. If, for example, the kind of study you're doing is like a clinical trial, where you know you're looking at a drug, and maybe that drug is something like let's say a chemotherapy drug. It usually is preferred that let your precision be around that 0.01.
Is it precision?
So do you understand why?
Is it precision you are talking of? You are talking of your level of significance.
Sorry, is it level of? No, I think it's it should be precision.
Because if you put your precision high,
okay,
it's extremely. You can even have thousands, something like millions. You don't know. Okay, maybe.
Okay, no. Then it's significant. Then it's significant.
It's level of significance. You want to say it's not precision. Because look at this one now. Okay. By putting the same, if you look at the denominator the same, numerator the same, we have done now. Putting 0.02, it has jacked up the sample size to 2,000. Can you see? Something that was with 0.05.
Yes. Wow.
It was 384. Now it's 2,000. If you run, that's what it will give you. Maybe let me just show you. Now, so this one instead of this one, 0.02 rather. Let's remove all these 10%. Let's see in the raw state. Can you see? Can you see? 3,400 something. Yes, I mean. So 2,400. So yes, jack it up. 2,401. Jack it up. So that's just it. Then let's just proceed. No.
I keep seeing that if the observed proportion is between 0.3 and 0.7, I keep seeing that thing in the software.
Yes.
It's just basically telling you that once your P, okay.
It's just telling you the range of the confidence you have. It's the same thing I've just explained. Oh no, by the time we go back there, I will explain it.
Okay. Okay.
Now, I think there's another situation here. Okay, I think this was just still talking about. Yeah, I think we have already talked about it extensively. This one is talking about attrition also. If you put it, imagine. Okay, look, this is another scenario. Instead of using 0.05, 0.833, that is 83%. If you use 0.83, 0.0833, so and you adjust for population of 2,800, and you adjust for 10% non-response, it will give you 220. But before you even do that, you'll see what it will give you before we even adjust first. Let's see that 0. It will give you a value less if the prevalence is 0.833. 0.05 level of significance of precision. You see can you 214? Can you see 214? It's smaller than that. 200 and 300. Because You only get that maximum with 50-50. Anything apart from that 50%, it will give you less. If all those other things are the same, 1.96, 0.05 level of precision, that 50% is the highest that will give you. Eh?
Okay. Okay.
Okay, so that's just it. Okay.
Thank you.
No problem. Let's continue here. If you want to now put, let's say the population is 2,800, as you said. So it will give you size of 199. Can you see? That's what we calculated here, 199. Now, if and look at what you are saying, a sample size of 200% will yield a confidence interval up to YY if the observed proportion is near over 70. This one is just used to explain the confidence interval.
Okay. Okay.
So now let's go back to this. Let's now put 10% here.
Okay.
So it will end up with 221, which is 2, which is on the 220 here. Can you see? And because of the decimal, what you get, you lose due to decimal. Okay, we have talked about the proportion now.
So when they say that it will yield a confidence interval of up to 0.01%, what does that mean? 99%?
Confidence interval what?
Because I saw it. I saw what they say it will yield a. I heard it said 0.01 wide. Did you see that?
0.1, no,
0.01 wide.
It's not 0.01. They put 0.1, 10%.
Sorry. Oh, okay.
It's 10%.
So what does this statement mean? Okay.
Well, inflate is a required sample size if the proportion is this.
And so the sample size of
for loss of 10% subjects. That is,
okay.
if you want to inflate to okay, I think no, that one is what we put in there. A sample size of 250 will yield a confidence interval up to 10, 0.1 wide. That's it.
I don't understand that language.
I myself, I look at if I'm coming.
Okay.
Actually, where he's just talking about what Dr. Balogun was talking. If by the time that is extreme, do you get the vision? It's extreme. You discover that, you know, when we talk about variability, 50-50 is the highest variability. Do you get the vision?
Yes.
We have already said it. So if by the time anything is less than 30 or greater than 70, for you to actually get what you want to get, you may have to increase your level of precision. You understand now? So that was why I was saying that it's not advisable to even use 50-50 by that time. It's not advisable to use 0.05, which is level of precision. You can, if you reduce the value so that you can jack up your sample size. Now, let's assume that instead of proportion, it's mean. Yes, I mean now. So in that case, what you put here, though I don't have scenario for that yet.
Yeah.
Let's say the standard deviation, just give me, let's say the standard deviation for, you are studying weight.
Yeah.
And standard deviation is 10 kilogram. And the unit of error, and you don't want to, if the mean weight is around 70, and you don't want to, your error, acceptable error is the mass, that 0.05%, 0.05, which is acceptable error. So you can calculate if the mean is 70, you don't want to miss the real value by more than 5%. What is 5% of 70? That would be 3.5. But 10% of 70 is 7. Let's put 3.5 there. 3.5. No, that's why I say what do you say? That's unit. You have to follow the unit of, because this is standard deviation. If you are talking of height,
Okay.
weight, whatever unit is used, that's what you are using. That's why it's a unit, it's not percentage. If you go and use percentage here, you are going to have, okay, let's do it now first. You come back and use percentage, you go to jack up your sample size extremely. Because the here you are dealing with mean, it's not standardized like the other one. So the coefficient of, or if you look at it, or, you know, I gave the
That's why I saw, or you give us the formula.
in the formula, you know, in the formula we have alternative.
Standard.
Now you use the
Yes.
coefficient of determination here. So, or instead of using this, we just use the coefficient of variation. But let's say we
It's standard deviation divided by something times 100. I'm trying to, is it N? Is it the population? I'm trying to remember that formula again.
that over mean.
Formula for over mean. Okay, the formula for coefficient of variation. Okay. Okay.
So can you see now? I give you 35, 34.
Oh, wow.
Yes, I mean now.
Okay.
Let's come back now. Let's assume that let's just use 0.05, which I use here instead of unit.
Yes. Okay.
We'll see what will happen.
Acceptable error.
Can you see? 153. Yes, I'm not. But it's not appropriate. You know, why you are not seeing big figure here, you know, when you come to just an assumption, we just use here. Yes, I mean now. Say yes, I mean. But most of the time, sir, with the this you need less. If you are dealing with mean and all those, you actually need less sample size. Because what the scenario I just gave that, what is the standard deviation of weight among the population? I don't think it's more than that 10% or maybe 15 or 10 kilogram or 15 kilogram. An average weight is around that 70. The year is the 5% of that 70 of the average I put here. But if you use coefficient of variation now, in that situation, you are not talking of this. This one is not there. We now talk about, let's say the coefficient of variation is 25. Then the acceptable error of the mean, you have to put it in percentage now. Let's still use 5%. So can you see? Give us 99. So that's how to use this one. So any question on it now? So we have talked about descriptive study now. So we have looked at the proportion and the mean. Any question?
No, sir.
People are not responding.
Sir, I responded though.
Only...
If you want to compare, you say, oh, you just calculate for one side and you use it for
what?
The comparative study.
One after the other. Who is talking?
If you have a comparative study.
Wait, we have not reached now. We are going there.
Yes, we are going there. Okay.
Dr. Dolapo.
Yes, sir.
Now, we're talking about classification, proportion. Okay, let's say you are studying anemia. And under that study, you are going to have a subgroup, mild, moderate, severe. When you want to calculate your sample size, what you are calculating is it for everybody? Can you subdivide them into, okay, out of a total population of 250 in my sample size, I'm going to put 150 in mild, maybe something like that, or as they come, when you classify them. Will it still be valid to divide them by 3 according to the categories of anemias you plan to study?
No. What you are using is, if it's anemia, is the prevalence of anemia.
Yeah, but now prevalence of, that's the general word. But anemia can be mild, moderate, and severe.
Yes,
data analysis.
But you are not using that one to calculate the. You are not using that one to calculate sample size, unless if your study is prevalence of severe anemia. Can you see? You say you are looking at prevalence of severe anemia. In that case now, of course, it will be smaller than the prevalence of anemia generally. So what it means, you know the implication of that one. So if it's going to be smaller than the severe anemia, what will happen to the prevalence? That it will eventually give you a smaller sample size.
So what you are saying is that it's not wise to allocate numbers.
Yes.
Let's say you want to study anemia and you are doing a prospective study. Will you get to a point, maybe you are getting more mild and moderate and severe?
It doesn't
Will you
matter.
get to a point? Hello?
I'm listening.
Yeah, will you get to a point and maybe when you get 150 mild and you only have 100 left, does it require you to stop collecting more samples about mild so as to make up for data from other categories?
And how do you even know that? Because before you even start, well, that's the way clinicians like to work from answer to question. Because you are not even supposed to finish your data before you can say, okay, this is the, because it's until you finish collecting all the required sample. Because for the fact that it's just like when they are doing election, they will say, Dogara. They may count the first, all the one they count. It may be one person that is winning. Doesn't mean that it's the person that wins. By the time you are counting the next one, it may be another person that will be winning. Until you finish counting, you won't know who is winning. You understand now? Until you have completed your sample size, it may be appearing as if the one you are doing, most of them are having severe. It doesn't matter until you have completed your this thing before you can know. Because later you may not see that all those other ones may be coming. I don't know if you understand me now. So trying to see that most of them are mine severe doesn't mean that the severe anemia will be more until you finish. And when you are doing your this, sample size calculation.
Yes, numbers should not be allocated to various categories.
No. How will you do that? That one is just the classification. Exactly. You will not do that unless you are looking for.
I asked, a study was being done and we are looking at proportion of wound infection, severe, some dirty wound, clean wound, contaminated wound, and they got to a point they say, oh, we have enough of clean contaminated wounds in our sample size. Let's look for another proportion that is dirty.
Let me tell you what really happened in that way. That they have not done the selection that is biased. Is biased.
Yes, it's biased.
Yeah, it's biased because they are not using scientific way to sample. We are not using probability sampling to sample. So that is why it was like that. That was why it was like that. If you actually use probability sampling, you are just okay. They are just recruiting and they are coming. They are recruiting and they are coming.
Yes. And you discover that one of the categories is not really well represented in the data.
Exactly, and the reason is very.
Just stop collecting from this and then focus more on that.
At the end of the day, the result just go to one kind result like this. So that is not scientific. Because you don't know what happened. Maybe around that time, maybe there are some injury in one local government that is slum. There are some injury. There are something that happened that bring them, that bring them to the hospital. And in that case, you have a lot of dirty. And after a while now, maybe within that, some other from other clean area now came. But if let's say you have already said okay, as they come, you have an estimate of number you will go to see in the clinic, and since you are doing your study over 3 months, and if you know your sample size is 300 and you are already allocated per clinic day, this is the number I'm going to sample. So for that clinic day, you are going to sample that number from the people that come and leave the rest. You wait for another, even though you have a lot of people that are eligible, you have already do your, either you use simple random sampling or systematic random sampling to get them. So you now spread over many days of those clinics. That will be more representative rather than just as they are coming. And I say, oh, we are getting enough bad wound. Let's stop that bad room. When new clean wound come, begin to. So it's not scientific. So that is why, oh my God, if you really understand statistics very well, many studies that people do is lie. And that's why I believe what this release said. Because this was a prime minister of UK Many times they wanted to do project, they say they do economic analysis and professor will come, expert will come. I say the study has been done, and this. And they say if you do this, this is how the poverty rate will be reduced by 30%. And okay, the government has okay, let's release the money. They will spend the money, and at the end of the day, nothing happened. Why? That shows that evidence you have to be questionable. So that's why it's not everything that anybody publish now. Once they publish now, oh, something at all found out. You don't know the right guy involved in the study. You don't know maybe a cook result. So me, I don't even base my decision on whatever anybody conclude. I would rather see the study and look at the methodology. If I'm okay with it, I will look at the result myself. I will interpret the result because sometimes, like one lady that did study now, Dr. Ikobo. Dr. Ikobo,
Yeah.
sir. This is your student.
Can we go back to the mean? Can we go back to the mean?
I will go to the mean.
Can we go back to the mean?
Okay, the mean. Okay, I will go back.
Let's go back to the mean.
Okay. So he did the study. They didn't interpret the study what they interpreted concluded is different from the result because they don't know how to put the direction of the percentage. And by the time they publish it, they will be referencing it. Yeah? So somebody just be referencing rubbish. So,
Oh God.
Please go back to the
yeah, so
previous one.
I'm
Just
there.
go back.
I'm there. So estimating me.
Oh,
yes.
you have passed it too.
No, it's there. This is it.
So my concern, I have two concerns here.
Okay, sir.
I'm not clear with how you got the accepted error. That is not in percentage, but it's in unit. Then the second thing is that if you are using coefficient of variation, you know, at that stage of determining sample size, you have not even collected your data. You don't have any statistics in front of you. So is it that you get it from a previous study? If it is from a previous study,
yes.
how do you calculate it? How do you calculate it?
Okay, thank you. If you remember, it's because you forgot, sir. In the previous one we did, we talked extensively about this coefficient of determination. Let me just show you, because
is it variation or determination?
Don't worry, the variation rather. Sorry, it's not. It's in regression. We talk about coefficient of determination. It's variation, coefficient of variation. I want to open the slide so that you can refresh your memory about it. It's good that you are raising it because there's no need rushing anything when you don't understand. Because the simple things first before complex things. Though most of the time people don't. Okay, I think what am I even doing? It's still on their slide. I left it on. I even left it on the slide on the.
You don't want to eat it.
Look at it, sir.
The potato that I gave you. Oh, tell me that I'm hungry. You say you are hungry and I gave you food. Am I that? No.
This push potato cup. Maybe they are forgetting that they are in public. You know that when you're on Zoom, you're in the public. Okay, can you see the slide, sir?
I've not started seeing it yet. It's blank.
Okay, I'm coming. Let me reshare. I was even trying to open the other one. There's no even need. Okay, let me just leave it. Let me reshare. Can you see it?
It's coming up. I've seen now. I've seen.
Okay. You see this formula on the right side of the slide is the one that talks about mean, using mean and standard deviation. This one on the left side, the one that uses proportion. P, Q, D, those are the things. If you look at Z, it's the same thing for both sides, which is a standard normal deviate. But P is the prevalent, Q is the 1 minus prevalent, D is the level of precision, which Dr. Balogun will be talking about, which you say should not be more than 5%. 0.05. Then when you now come here, if you look at all this, they are standardized. Whenever you express something as percentage, you have already standardized it. It's a ratio. It has no unit. Because when you say something is 5%, it's a ratio. And the funniest thing, even the percentage you express in decimal and in percent. Like now, this P now, when we say 0.5, this 0.5 means 50. If you decide to put 50 times 50, no 50p, then 100 minus 50, making Q50, and divide by 5, you now write it as 0.05. It will give you the same answer. But if you express the numerator as 0.5, you must express this one as 0.05. Can you see? If you express the numerator as decimal, the denominator must be decimal. It will give you the same answer. But if you express numerator as percentage, the denominator also should be expressed as percentage. It will give you the same answer. So this one is already standardized because the denominator, the Z, is a ratio. It has no unit. The P is a ratio. Q is a ratio. D is a ratio. Either decimal or percentage, they are ratio. They have no unit. But when you now come here to this one for the mean, this Z here is a ratio. No standard normal deviation. But the S here is a standard deviation. The size of it depends on the unit of what you are doing. If it is weight now, the standard deviation of weight will be around 15, 20 kilograms. But if it is height, the standard deviation, if you measure height in meter, it will be 0.2. If it is a kilometer distance you are measuring, maybe the standard deviation will be 150 kilometers. You get this deviation. The mean will be 1,500 kilometers, standard deviation 150 kilometers. So the issue here is the standard deviation is in the unit of the, and if that is the case, the denominator should be in the unit, to be in the same unit for it to cancel out. That is why you cannot use this E. You cannot just put 0.05 because you want 5% to be there. It's not possible because it will not cancel out. The implication of that is that you may have extremely large sample size or extremely small sample size if you do it, depending on the unit of the standard of the T you are using. If the standard deviation is something for the height you are measuring, the standard deviation is 0. something, and you are now putting this 0.05 here, what will happen is that it will jack up your sample size. You know, it will make your sample size small rather, because the standard deviation, which is numerator, is a small thing for height, meter, 0. something. But if you are now talking of kilometer on weight, that the standard deviation will be around 1 kilometer, around 200 kilometer, or weight that you can say standard deviation is 20 or 115 or 17, and you put this in there, it may jack up your sample size. So denominator must be in the same unit as numerator. So that when you have, if you put in the standard deviation of that thing, let's say you are talking of weight now. Now that level of precision, which usually set as 5%, you will not put 5% there. When you now calculate 5% of the mean and now put it there. Because after all, the logic behind that is the level of precision, is maximum error of estimate. You don't want to deviate from the origin, from the parameter. You don't want to deviate from the population value by more than 30%. You say 5%. But since it's not standardized, you now calculate 5% of that mean and put it there. That is what you see there as the unit. You say that you put the unit, you want to put there. But you are not going to put the mean there. It's not the mean, no. It's the how much you don't want to deviate from the mean of that attribute. That's what you put there. Or otherwise, in terms of doing that headache, you use this formula, but you now use coefficient of variation. Because when you put the mean, you have to mean standard deviation divided by the mean. 100 times 100. It will now express as percentage as if it's proportion. You now calculate your P and Q and use this D directly. You just use this formula as if you change it to proportion. So it will give you So that was why even in that software, they make provision for that. So they make provision for this form and for the one that use the coefficient of variation. So if you go back there,
I have understood that part, but where can we get the coefficient of variation? How did we get, the first part is very clear. How did we get the coefficient? Is it from a previous study or how?
Of course, now where did you get your proportion? It's not from this video. If from this video study you quote mean and standard, it's you that will calculate it. They may not calculate it for you.
No, I'm talking of the coefficient of variation. Are they going to write it like that in the previous study?
Is from standard deviation and the mean. In the previous study, they will give you the mean plus or minus standard deviation. Just put the standard deviation divided by the mean. That's 100. That's the coefficient of variation.
Standard deviation divided by mean
times
100 equals.
Then look at it now. That's what is down here. Coefficient of standard deviation divided by the mean. That's 100.
Okay. It's very clear now.
That's great.
Very clear.
So any other issue? Somebody pay money to UBZ because they use transfer and it doesn't carry name. Who is the person? Is it from anybody here?
I saw a new person just came in. It seems. Let me check whether he's still there.
Is it no? Is
he has
it
gone?
Afi?
Somebody came in.
No, General Afi came in. No man, he has gone. He's one friend of mine. He has gone. He even came in. I greeted. I said, General Afi, now for you. I have not seen you for some time. So he came in and went out. So he's a neurosurgeon. He's was in National Hospital here. I think he's back to Jos now. Those are the people that they are waiting for meta-analysis. They are the one that want to benefit. They want this regression, highfalutin thing. So these are you mentioned better to study very well. Okay.
I would like us to also include a systematic review and randomized control trial. They are not there. Systematic review.
Is it the issue there? I want to limit myself to any statistics. I don't want to go if they are for me, I can do that. But when people are not encouraged, you don't know that I put in effort to get material.
No, when it gets to that level, you increase the fee.
No, I mean no. Let me tell you so.
Yes, now.
No.
When it gets to that level, you increase the fee because people are going to be very few. People are going to be few.
We are going to be few also. It doesn't make much sense also. Still, let me tell you, for what I want now, like you now, I want all of you here to subscribe to the material. If you want to be enjoying all these things now, if we subscribe to it, there are some people that don't want, they just want something like that, cheap thing. So let them get it. In that case, is the number I need. The one that have one big thing, we can manage the number small and vary the price. I will know that the people that need it. So in marketing, you target the two of them also. You target both. The one that want the cheap thing, you give them better. So far, they are in number. So it's the number I need. And that's why I encourage everybody. That one, you don't lose anything just by subscribing. And any other people that ask you questions about, and you have watched all those things, you know what you have inside. You can tell them, oh, subscribe, you see, I want to watch this video, I get this material. You get the answer, what you're looking for there. So through that, if you have not done it, it's not likely you will ask people to do it. Because most of the time they say, how do I do it? So that is why I want every one of you to do that. So no problem, we look at it. Even this sample size, you are the one that raised it. Though it was part of my module, yes. I remove it later. Because it's dicey, I have to put in a lot of effort to get my facts ready before, because it's a dicey. If you read many books on samples, I will give you different things. So I have to do a lot of study to reconcile a lot of things. So if you are talking to the public, you don't just come and give anything that is, any information that is not validated. You have to give valid and standard information. And it takes effort. It's not just somebody just sleep and wake up and get it. It takes time and this. So that's just it. So I think we proceed.
Okay.
We proceed now. So you get it now. So this one. So that is what was confusing you, right? You have got it me right. Okay, that's good. Well, let's proceed. Now we are through with one group. Let's go to. You can see now we trash a lot of things under this one group, and some of them are applicable in the other one also. The issue of giving 5% attrition, how to adjust for it, there. It's the same thing all over. I want to include in any, as you are going to see. Now, when you now have two group studies, so do I put, okay, I put one example. Most of them are proportions. See, I was looking for, because some of these things I brought out are the one I've helped people to calculate with I brought that. This I was thinking, I have some that are on me there. I didn't see. I was looking at. We're going to lay our hand on it. Look at the formula for proportion. Look at it. If you look at it, what makes this one differ from the other one is point out. The other one has Z, but we didn't put it alpha because there are only one Z there. But it's actually this Z alpha that is the descriptive study. That is standard normal deviation that corresponds with level of significance. That is what this one is. What is there? This Z alpha is what is in the other. Why is this in non-show? This Z alpha is what's in the other descriptive study. The beta, Z beta, which corresponds with power, 1 minus power, it's not in the other, because in the other, you are not looking at difference between two things. You are just trying to estimate. That's why there's no power criterion there. But you will see that because there are two groups, you have P1, prevalence 1, and prevalence 2. We are looking at two prevalence.
What I'm seeing is just the WinPepi view. I'm not seeing. Okay, I'm not seeing what you are describing.
I think I didn't share. Can you see the slide now?
Yes, I'm seeing now.
Okay, what I was saying, I was talking of this. Can you see? Z alpha, Z beta. This is significant criterion is Z alpha, which is 1.96. The power criterion is Z beta, which is 0.84 for power of 80. The other one 1.96 for 95 level of confidence. While this one is for 80% power is 0.84. If it is 90% power, is 1.28. So those two are constant. So the one you are checking literature for is the P1 and P2. The prevalent in group 1, the prevalent in group 2. Q, of course, is 1 minus P. So the difference between P1 and P2 is, you can call it D also. It doesn't really matter. It just means the difference. You remove one from the other. It doesn't really matter which one you remove, because in the formula is a square. Either you remove big from the small, either you give it positive or negative. When you square it, it will be positive. So you will see from here that the smaller the difference between the two groups, the bigger the sample size will be. The bigger the difference, the smaller the sample size will be. And if you go to the mean side also, can you see? Instead of talking of proportion, you see standard deviation 1, standard deviation 2 over m minus m1 mean 1 mean 2. So that's standard deviation of group 1, standard deviation of group 2, mean of group 1, mean of group. D also is like saying mean of group, the difference between the mean of group 1 and 2, D. Just like the other one, it doesn't really matter which one you remove from which, is squared. If you count in the negative, you count one. This option you will see, instead of writing S1 standard deviation 1 as they just put S. This S is the pool standard deviation. That is, what you do is to add the two standard deviation divided by 2. But in that formula, you have now to multiply everything by 2. Can you see? This one, they usually you see is exactly like this, especially when it comes to experimental design. No, experimental design is not observational study where you say, okay, in the previous study where they have compared the two, what was the mean between the two groups? Experimental design just want to estimate, and I just want to perform his experiment, and that's okay. He has a control group. So that is why sometimes it's only one standard deviation they get, and they just put it and multiply by 2. Though if you can get the two standard deviation, 2 mean and standard deviation, you can calculate the pool and use this formula. So most of the time for experimental design, you will see it written in this form. But both all of them are the same, either observational or experimental. All this formula is the same. Now, because it's not about what the experiment you did, it's about group. You are talking of 2 independent groups. You are looking at difference between 2 independent groups. Okay, let's quickly look at example. Look at this. If in a particular study before, prevalence was 5.41% and 4.58%. This is an example. If you calculate, it will give you, can you see, 10,000. You know why the prevalence in the sample size is so high? Because the prevalence, they are very close. There's no much difference. The difference between the two prevalence. It's not the size of the prevalence. The prevalence is very small. But the difference between them is small. That's why, because the difference from the denominator. It will jack up. We're going to see how that sample we're going to look at. You see the difference is much. It has reduced the sample size. Further, this difference is 20%, is even much. Can you see? So what determines sample size for two good studies is the difference you are looking at. If the difference is big, the sample size will be small. But if the difference is very simply small, because it's from the denominator, the sample size will jack up. So let's look at the way we look at use WinPepi. So in your WinPepi, I've shared the WinPepi. Can you see it? Nobody is answering. Can somebody see it?
Yes, yes.
We can see it. We can see it.
Yes, sir. We can see it.
Okay, sir. Yes, I want to go back to, maybe I just can't see it out. I want to go sometimes. Okay. Let me come out and let me stop sharing. Let me come out. I want to go back to the beginning of that thing. Yeah. So I went back, I off it and now click on it again. You know, if you remember when we started with this descriptive, when it opened like this, we went to describe. But this one is compare now, because this one has to do comparison of 2 independent group sample. So you click on the first one. Don't worry. Stop sharing. So when you click on it, you will see up. You know the other one for descriptive, you look for the option sample size, but the option is when you go up, you will see, I don't know if you can see, you go up, You now see, you see sample size here beside class, means class. You click on it. Now give you proportion comparison. We have mean comparison also. Can you see? For proportion comparison, just click on it. So by default, it give you. Can you see the level of significance? It will not. It doesn't say 95 here, but it just say 5% level of significance. It's the same thing as when you see 95. Then it puts 80 power by default. Those are the default we use. Power, you can change it. 80 power. You now see the ratio between the two. You want each group to be equal. Then you want the issue, the group to double, maybe control to double or whatever. You can put it. Now, you now see proportion. Proportion B, proportion A. You can say okay. Proportion that is just put one of them. Let's put. What was the other one? What we saw the other time? Let me go for it. Yes. So this one is 0.541. 5.4% is 0.541. No, it's 0.0541, I think. 5 is 0.0541. You have to type it as decimal. Then you now say, okay, the second one, because the option is given here, you want to see, you want to put the odd ratio, but you are not putting the odd ratio, you are putting, okay, the size, the proportion of the second one, which is 0.0458. Can you see if you want to allow for inclusion? Can you see that 5% or 10% your attrition, whatever? This is where you put. Otherwise, just run. Can you see? It give you 10,000. If you look at it, because of calculation, you just see this one. Know you what you lose to decimal. This one 10,795. This one is 10,813. For each group, can you see? Is it 21,000, then 10,000 for each group? Any question concerning this one? Because you can.
Please go back again. So I really understand how you get to this question.
Look at it now.
With WinPepi, because I'm trying to understand in my own sample size what I did. You know, I was comparing me, so I was trying to see.
Is it me? Is it me? You use your own proportion.
Sir, it's me that I use. It's me that I use.
We have not reached me. We go and do me now. Wait, it's proportion we are doing now.
I just want to see what happened.
And what happens?
How you did
click on this proportion. Maybe you can see.
It's giving me a different table. That's what I was wondering.
So are you doing it with your this?
Hmm? Yeah, with the WinPepi now. You click on proportion or what?
Look at it now. Can't you see the screen?
How did you get to this place first? Go back, sir.
Okay. Wait.
Okay, sample size. I've seen it now. Yes, I've seen it.
Sample size up. You click on it.
Yes, okay. Okay, all right. I've seen it now.
S1, proportion comparison.
Okay, okay.
So you now type
all right.
A value here and type value proportion A, proportion B. Any one of them. Okay. Don't put anyone in the same thing to give you. Either you put A or these two something. It will give you. Let's use the other value.
Why is power set at 80 and not 90?
And that's the common. Most of the time, is power is 80 now. So is it 90 you use your?
It's 80 that I use. So I was wondering.
Why are you asking now? Because that's what people.
I want to be able to explain the reason why I'm using what I'm using.
And it mean that if your supervisor doesn't give you the explanation.
Because there was a time I was calculating. Somebody was saying that maybe if I increase the power or reduce the power, it will reduce my sample size. So I was wondering what is the relationship of power with the sample size.
If you increase the power, it will increase.
It will
increase the sample size.
Sample size, okay.
It's
Okay.
numerator now. The power is numerator there, so you increase it to increase sample size.
Yes. It
So,
will increase the sample size. Okay. Yeah.
so this second option, and look at this one. If you look at the difference between 2.78 and 1.5 something, is more than the other one, because that one is 5.4 and 4.58. Can you see? The difference here is very small. But the difference between in this one is bigger. So eventually lower the sample size. Let's put it in 2.7.
Hello,
Yes, sir.
can I ask a question?
Yes, sir.
The proportion that you use in calculating it, did you multiply it by something because it's 0 point something, P2 is 0 point something. Did you multiply by a factor?
No, I just express as decimal now. Instead of the, it's in percentage. Now, if you want to change 2% to 100, okay, someone is raising and after you.
But is that what we should do? Is that what we should do when we are calculating it? We should
Okay,
change it to decimal like that.
Listen,
like 20% now is 0.2.
20 by yes.
Okay, so that's how we should do it.
Yes.
Okay.
If you look at,
okay.
Can you see? Are you seeing the screen? Are you seeing my screen? I'm coming, James.
It's only the WinPepi I'm seeing. No?
Okay, let me share the. I thought I have shared. Okay. Can you see the screen now?
Yes.
Now, if you look at it, they say 2.78 here. It becomes 0.0278. Can you see? 1.54 becomes 0.011. But in your calculation, if you look at that also, in your calculation, if you decide to say 2.78 and use 1. It's okay. But your denominator should maintain the same thing. It will give you the same answer. Are you understand?
Okay.
Whatever, if you change it, you leave it as percentage in numerator. You must leave it as percentage at denominator. It gives you the same thing. But when you are using the WinPepi, sometimes it specify what you should put there. Look at it. It say proportion. It didn't say if it's percentage, you write the percentage in front, just like the one you have in front of this down here. If you want it to push as percentage, if you put percentage in front, but as you say proportion, you express it as a decimal.
Okay.
Yes, that's fine. Like now, okay, yes, you are raising hand. Go on.
Is that
Yes, sir.
to detect odds ratio? Oh, sorry.
Hello, sir, please pardon my ignorance. I joined the call late today. Which software are we using? Which software is this, sir?
WinPepi.
WinPepi. Okay, we don't have access to this one, no.
I thought you have it. When I was here, you didn't. I will have. You can download it. It's free. You can, if you Google it, WinPepi, you can download it. It's free. You can download it and install it. It doesn't even take you 1 minute to install. It's free.
Okay.
Yeah.
Okay.
Yeah.
Thank you.
Welcome. So.
Yes, sir. Okay.
What do you say?
Hello, sir.
Hi.
Go on. The ratio of sample size is B to A. Is it that is if you want one of the sample size to be B and the other one of the groups?
No. If you look at it, it depends on the information provided in your literature. Sometimes you may not have it may be odd ratio they give you. Yes, I mean. So in the odd ratio there, if it's odd in your literature, it's odd ratio you get. You don't even have the proportion.
Yes.
You feed in the odd ratio. It will work.
Okay.
Yes, I mean now. That's it.
Okay, I now understand. Okay.
But if you have the value for if that's the case, you don't need to put the proportion. You just put the odd ratio. But of course, you have to have the value for the first one.
I see.
And if you don't have the value for the second one, you have the odd ratio you put. Yes, I mean now you have the value for one. So if you don't have the other, you put the value for the two. That's why I gave all those options. Then if we use this one now, 0.078, 0.0278 rather, 278, 0.0154. 54. Can you see? Each of them 2,150 something. So let's move further. Let's look at when it is mean. Yes, Odusolu, since you say you have mean something now, you give us the information about your mean. Let me, if it is mean, if it is mean, so you click on comparison, mean, S6.
Yes.
Can you see now? Can you S6? So it give you by, can you see 5%, 80, then it give you pool, you see pool variance, or you have variance for each of them. And the different
I use pool variance.
Okay, what is your
I calculated the pool
variance? What is your pool variance?
14.45. 14.45. 14.45.
I've done it. Then what of group? One group. What is the difference?
The standard deviation.
No, you don't need. Once you already put pool variance, what is the difference you wanted to detect?
0.05.
The mean?
The D now.
And that's the
mean.
mean.
Okay, the difference in
the mean. What did you use?
But let me look for it.
Lodo.
Sorry, I'm looking for it. 16.29 minus 12.64. What's that? The first one was 16.09. The second was 12.64.
And do it now. That's around 4 now. 16.
I'm using my phone to calculate. 16.09 minus 12.64.
16.09. 16.09.
Minus 12.64.
Minus 12.
And 12.64.
Make it 3.45. 3.45.
3.45. Okay.
Yes. Are you sure? Because that what we have here is 42.
Possible.
You know, you yourself.
The pool variance I thought was 14.4.
No, it's not. It's not. Okay, sorry. Is it pool variance or standard deviation? Which one? Is it pool variance or pool standard deviation?
It's the pool variance that I calculated. Huh?
What was this? Okay, what was the standard deviation for each of them? Give us the standard deviation for each of them.
Standard deviation for each of them. Okay. Yeah? The first one is 16.09. Sorry, the standard deviation that I mentioned. 16.09 is the first for the first one. Second one, 12.64.
12.64.
And 16.09.
And 12.64. And 60. But the difference we are looking at is not the difference in the standard, it's the difference in the mean. The difference between the two means.
Yes. What was the difference mean too?
What's the difference in the two means?
I used the wrong formula. Working to the answer, really equal. I calculated the pooled the standard deviation. Then I now input it into the formula mu1 minus mu2, social mean quality of life from previous study.
Oh no, is the standard different in their standard deviation you use as the different?
Yes. Yeah, it's the difference in their standard deviation that I use as the difference. So from what I'm seeing here,
their
mean. It was their mean that I calculated again.
Is it the difference in
their mean? I made a mistake. Yes.
What are the mean? What are the two means?
The two means. The first mean that I got was 16.09. Second was 12.64.
That is just you say they are standard deviation. How can they be mean? How can you say they are standard deviation? You not say they are mean? How can even
that was what I wrote here. That was what I calculated. That was what I got as mean. That means I got the wrong information for the standard deviation. I inputted the wrong thing. Hey, Jesus Christ.
So what I'm seeing here with this one is 78. 278 each of them.
When you want to manually calculate it,
this is what you got.
The denominator is actually the mean to use.
Is the difference between the mean?
Yes.
Yes.
It's
not the difference in the standard deviation.
It's the difference.
It's the difference.
That's what you did now. Was that not what you did?
Yes.
it's correct. So you did
What
different.
did you get now?
No, it's not the. It's
What's the answer? I
278.
got 275 was what I got.
It's the same. You know,
275.
this one usually higher because of it's computer. All those what do I call it? Decimal. You lose value by using who you are using hand. So it's the same thing. But what you have done now is the wrong information you put in. What you are telling us is that
so it was the standard deviation that I put.
Is the difference between the mean that you are supposed to give. What are the two means? What are the two means?
I think that value I gave you is the mean, Jerry. Is the mean. That was the mean I got.
What of the standard? You don't know the standard deviation. Okay, this
I don't think I know the standard deviation. It's not there.
These are the untransformed value, the untransformed. These are the untransformed value for the quality of life. Because it's untransformed value. So the standard deviation should be a smaller something. No wonder your sample size was so big like that. Because it's not supposed to be as big as that. That's why your standard deviation was so big.
Well, the one I calculated initially was something 200. My assessor said it's too small. I should make it larger. So I had to be doing. In fact, I went on tutorial, going from places to places to increase sample size. It was Mr. Kishola that taught me the formula for this one. I tried to calculate it, Daddy.
Yes. Both of you now means calculated. You didn't get what they taught you.
God. So, but I've used the. I've got to.
Okay, just for you to, if they raise it, you will not say, you have to use that is the mean. If they ask you, say, is the denominator is different in the mean you are detecting. It's different, you are detecting the mean of the
But you are still safe for this one. Because
so the funny thing is that the difference between the mean also can be 3.45. Yes, I mean now. Do you get it now?
Okay.
So it can be. But you will not go and say there is because here now the standard, what you put in as standard, that's the big problem. That's why they can catch you. Because if they look at the value you are seeing at 16.05, 12, they are like an untransformed value. The standard deviation is not up to that, it's around 4. Something like if you see the one we have done, it's around 4. It's not up to. So what we are supposed to put there as standard deviation was maybe
the standard deviation, you're not even supposed to have to all these 16 that I'm seeing.
Let's just say 4. Let's say this one's 5. Let's just say 5. See what we give you. It will even give you small value. Let's say the standard deviation. Oh, the standard deviation also was. Anyway, just leave that one. Difference between the mean will not be actually. If this is 4, 5, the difference between will not be up to maybe 1.2.
So you have
Let's say the difference between the 1.5. Can you see?
Excuse me.
You even say 1.
Hello.
Yes, sir. I'm
listening. Hello.
Sir, go on, sir.
You mentioned difference between the mean, but now you are now calculating difference between standard deviation. So is it different between the standard deviation or different between the mean?
It's the one that means it. It's different between the mean. You put in standard deviation here. This 1 and 2 standard deviation 1, standard deviation 2, or you use pool variant.
These are the difference between the mean.
The mean, yes. You now put the difference in the mean as the difference.
Okay, now when you are using the variance, if there's no need, there is still any need for difference between the mean.
Of course, now they have their own place now. Instead of using this standard deviation, you do pool variant. If you put pool variant, its option is or you just put the pool variance here and now put the difference between the mean. Yeah.
Okay.
Does it make sense now?
It's clear. It's clear.
So,
but you know that there's another formula. You know that formula of 2 into bracket Z alpha plus. If she just all she needs is just 1 standard deviation there now.
And that is that you can use 2 pool standard deviation or just 1. That was what I said the other time. That's the essence of using this pool. That's the essence of using this.
Okay. So you understand what you can do? All you need to do is okay.
How do can we substitute the the mean for if you want to calculate pool standard deviation now, can we impute the mean instead of the standard deviation to get the pool standard deviation?
How can you know?
Variance,
All of them have their space. If you want to use pool variance, you don't need to put standard deviation. Once if you look at it, say you can see now. If you want to use pool variance, you just put the value of pool variance and now put the difference between the mean. So the pool variance, I mean, let's say it's 16 now, because that one will be square of standard deviation. You examine now. So if let's say the pool variance is 16, give you something like this. Or if the pool variance is 18, you can jack up the or the pool variance, let's say is 27. 5 times 5, that's 25.
But so is there any way, because Dr. Dusholu, it's important that you can still, there's something she can still do about her sample size before she goes in. That is I know that from her sample size.
What she does need to do, she has already done the work, is to go and work from answer to question and manipulate and manipulate.
That's what I want to tell her. Exactly. Just work from answer to question.
This is what the pool variance, or you can say this is what the standard deviation is, or whatever pool variance, what you put in the formula. You now work and I just say this.
Do you understand?
There are some people, if they want to catch you, they say, where is the, let us see if they know that you have started telling lie. Some of them may say that, okay, can you share where is the work, the reference? But most of that they will not ask you.
Where's the work?
You just have to.
I even have the reference for the mean. So it means
what she needs is to get the literature. What she needs, and let me this thing.
Sometimes you can get a literature that suits what you have done.
Exactly. That's what I'm about to say.
Very well. The one that is closer to what you have done.
You're fine. Because you're covered any which ways. Because you added. At least you added your sample size was sufficient enough. It's just that you did the calculation wrongly. So once you can get it, like what Koduro is telling you, so that you not carry it inside the exam.
Sorry, may I say this?
Hello.
Go on.
Yes,
I just want to find out whether what you are discussing, if there is something that can be done. What if you remove some few samples from what you have and do a standard like a pilot study and say this is what you use to calculate your study?
Oh, I see.
Yes, that's a very brilliant. That's a very brilliant one.
Rather than be looking for,
yes, you are right.
You can separate a small sample out. What you need is that subsequent analysis, you will exclude your pilot samples.
Oh, yes. But that will reduce her sample size.
No, you won't do. No, what you just do is that just like what Dr. Balogun said. No, they will not know now. You just remove some data from your DC. You look for data that suits you. When you remove it, you analyze it. You just suit a value that fits into your calculation. You not say you did pilot or you did like a small pilot study to. No, you could not get literature around our own area. You do pilot study and you now use to get the.
Okay.
But you will have stated that if it's pilot study, you will have stated because you have submitted. Maybe you have submitted the something.
That's it. That's it to your proposal.
It's already
I believe Dr. Duro.
Yes,
no, sometimes there are some little things that can change you. If you propose to do something and it's not feasible, whatever small alteration you do, when you are not writing your final paper, this in your work, you include it there.
Right. Okay.
Okay. Yeah. The problem that I have now is that I have the mean, but I don't have the real standard deviation. Let me go and check. If the standard deviation will still give me something close to that.
What are the means? What are the means?
The mean is the 15.09 and the 12.64. They are the mean. Okay. The mean quality of life for people with support and the mean for some people without support. But it is those mean that I now use to calculate in the pool standard deviation instead of finding the real standard deviation. That was where the problem lies. And you understand, sir?
What do you use your standard deviation?
The standard deviation is what I did not use. I used the mean as standard deviation again to get the pool standard deviation. which was wrong. And now you
Which
put
of
into
the
that
means?
formula that you gave.
Oh,
Yes.
which of the means did you use?
You
It's
know
only
what
one
you
of the
can,
means.
you know what you can do.
I use the 2 means to calculate the pool standard deviation from the formula for standard pool standard deviation.
What
I
you
wish I
can
can
do,
show my screen.
what you can do, yeah, share your screen. Let me stop sharing. Share your
Let
screen.
me see. We continue. I will share it. I will look for how to share it. Let me get to Zoom and share it.
Okay. What you can do is very simple. You know, is good, too good study. You will now say that you will know the mean for one group, the supported group, or maybe or unsupported group, and now say that you expect the difference to be this. Is the difference you now use? You just put the difference that we just fit into what you have. So go and put the right standard deviation and try to look for denominator, the difference that will give exactly the sample size. That's all.
Okay, allow me to share, sir, so I can share my screen.
I'm coming because let me share first because the thing is not allowing you. Let me share. Maybe after sharing, I'm stopping. Maybe it may allow. You only host all participants.
Okay. Am I allowed?
Yeah, try now. Advance. I've already seen it.
I want to even get open to that sample size. Okay. Okay, yeah.
Is it sharing? Oh, yeah.
Yes. So this is, let me go up. Can you see?
Yeah, we are seeing it. We're looking at it. I'm looking for the standard deviation.
Is it because it's word? It's not scrolling, no.
No, it's not because of that. You should scroll. I cannot scroll for you. You should scroll. Double click on it and see.
If she used this formula to do, if this exists, like in terms of being able to use a pool standard deviation, that shouldn't that be right?
Wait to n plus n2, and this formula for pool standard deviation. This is not the.
Yes.
This is not.
This is the formula. That
So
this
if
is where now improve.
Let's see the original formula for the sample size.
Maybe it's okay then. Let's see the original. Yeah, that's the actual. Yeah.
So this is from where? This is the one I used.
So let's
the
see.
formula that you told us now.
Yes,
Exactly.
Yes, this is the formula, the one that has 2 in the front, the third option is the one I show. Now, if you look at it, so with the formula is very straightforward. I don't know how you now went and miss it and now go and use.
It was what I was taught.
Is that what he taught you?
Okay.
No, he cannot do that. He cannot tell you that. That U and UI, is this standard deviation? Is mu now?
No, that mu is me, no. Dr. Dusholu. Let's go down. Let's go down.
Go down.
Let's keep going down. Let's see what you do.
Go down. This mu 2 minus mu 1 square. These are mean. This mu and mean. The standard deviation is the one you row up here. Show you. So that 16 and this thing is you are supposed to put the 16 and 12 or something here. Yes, I mean down. But no, that's what you did now. This and this.
It's correct.
Yes, but for the full standard deviation, I used the mean again as standard deviation to get the full standard deviation. This place.
I don't understand.
How can you do that?
That is what is wrong.
So
that's what I was taught.
Who taught you that?
Dr. Drew, what did she do?
No, you cannot. Kishola cannot say that.
So what did she do? Please, I can't
see. By that time. It's not possible. It's not possible.
I want to learn. I can't see. What was wrong with this formula?
There's nothing wrong with the formula. It is what is substituted. Look at what is substituted now. That 14, okay, go up. Look at the pool standard deviation. He now put 12.6 for which is the mean, and 16.9 to calculate. Instead of him to put standard deviation there, he's putting mean to do the post. He's substituting mean. He's supposed to substitute it with standard deviation.
I thought it's mean. So what's in the front? Look at n now. N equals to 2 in brackets 1.96 plus 0.9. I thought the underneath is supposed to be difference in mean. The mean difference.
It's not the mean. This one has nothing. Well, I don't. Okay. Show before you substitute it. Show or go up and see where the post standard deviation formula is. N. It's not mean. It's n. It's sample size. That one, there's no problem with that. There's no problem with these two. But what he has problem here is x1 squared plus x2 minus 1. This x you are seeing, he now use me. Instead of putting standard deviation, he put me.
Oh, I now understand. Oh, okay. Oh, I now understand what happened.
So I think it was a mix of.
So I have to go and look for standard deviation that will give my working to the alpha.
When they do the study, where is the standard? Where is the literature? Where is in your literature? Where is that?
I'll go and I will look for it. I'm trying to look for it now so that I will tell you. I reference
the deviation must have been presented with that mean. It must have been plus minus something.
Yes, I will look for it.
So your supervisor, they didn't read it.
Yeah, most people
you didn't know about it.
What I'm just also, maybe another thing is that can't she just use the formula directly instead of doing all these pooled standard deviation up and down? If she can get that.
And because why you did that is because of the type of formula you use. For you to use that, the one that has single S. If you have used the one that has the 2 now.
Yes.
Even with that also, you can still make the mistake. If somebody puts standard mean instead of standard deviation, you can go and put. You know, when somebody tells you something, you can't you question. That person cannot tell you, it's you that just means it. Maybe you ask you, where is the something for this one? You just mistakenly put it. There's no way. Even if it tell you it's a mistake, you cannot do it deliberately. It's not possible. It must have been a mistake. Don't forget. Okay, let's continue.
Okay, all right, thank you.
Stop sharing. So stop sharing. The time is gone. The last one I want to just show this.
Let's go back to that. Can we go back to that WinPepi? There's an area down. And that's what we confidence interval.
Okay.
Optional. Required width of confidence interval for difference. What is it for?
Is it required width of confidence interval for difference? If you want to, that one just allow for inclusion of. Okay, this one is allow for enter space optional required width for. Well, that one, if you let's just say confidence interval width. Let's give a value. Replace the power requirement. Let's just give a value. Let's say 0.1. That is 10% confidence interval. Let me put, before I put it, let me first of all calculate, put a value here first.
Yes, sir, this 0.1 confidence interval, does it mean the difference between the two confidence intervals?
It's the width of the confidence something now. It's the width. Okay, 80 is removed here. It's the width. Okay, it gives 274 per. So let's now put that option there now. Let's see what it will give. 0.1. Can you see? It has, this one has the width of 0.1 for the 95% for the different required sample approximately 153,000. So I think this was what the issue Dr. Balogun was raising. You know, is this type of issue they were raising all those when they say if something below between 0.30% and 70%. The situation, if you want to skyrocket the sample size, that is what you do. So like now, if you are doing a study maybe for a project for maybe a development partner now that require, they have money. So they want to do a lot of, like all those ones that this Jane they are doing. So you just want to justify your sample size. That's how to do it, manipulate. Because everything, people, even people that don't know anything about statistics, because the funders, when they come, the funders also don't know anything about it. They just bring some people they think expert. And those ones, also because of what they call the person to come and do, they just begin to raise some option. What is the validity of this? What is this? So that is why people just look for something also to bamboozle them. Just put this type of thing to increase the sample size. So somehow it will, and if your sample size increases, you mean that the power has increased also. Okay, let's continue. The last one I just want to talk about is if it is pair observation, pair. So I have to go back to the beginning of, let me, yes, I log off the Sunday. If you open the WinPepi new, instead of, here is comparison of two independent groups described, there is pair. Pair, you click on pair. You click on pair, so you see yes, no, match, pair, to see pair observation. Yes. Oh, there is one. Wait. Sorry, what am I even doing? Pair observation, you now go to sample size. Sorry. Sample size. You will see the first one, McNema. If you are dealing, when you say McNema, you know that it's proportion. When you say pair T is mean. Can you see now? He's talking of mean. He's talking of mean. This one is talking of proportion. Just like what you do. The odd ratio to be detected or matching power, you can just put, okay, the compare. If you look at it, you still have 80%, 5% power here. So let's say what you want to detect is the odd ratio to and the expected percentage of pair with the descriptor observation. So let's just say the change, maybe you expect 0.1 or 1.5, 50% change. I don't know if that one. Very much. Okay, I think it's what I put there. This ratio, let's say 1. Let me even put 1 here. Cannot be 1. 1.1. Yeah, 3,000. It's arbitrary value you just put there. So when you are dealing with repeated measure, this is the way you know how you do it. Then if it is mean you are dealing with, no, it's not, that's on T, pair T. Here also, the difference this is the one most of the time in experimental research, that's the one people usually do. So you expect 0.515% different to be detected. Then standard deviation of the difference. You remember that the pair T, the standard deviation of the difference, this is 0.12. Just give me. So you know that if it is repeated measure, the sample size is actually smaller, somehow, because the variability you are looking at is not much, it's within. I think it's this one that is too big. Let me just put 1.1 here as jack of the sample size. Or let me just put 0.01. 892. Any question? So if it is peer observation, this is where you come to do it. So if you go back, everybody just go back, go and yes.
So it's like I said, the only thing you put in was just the difference you want to detect. That was all you.
What is it?
It's like I said, the value. The only value you put in was the difference.
And if you look at the formula, for pair, you know that it is very simple. So the difference and the look at it now. The difference and the is 2 things, and the standard deviation of the difference. If you look at that formula also, the difference and the standard deviation of the difference.
How do you get the standard deviation of the difference?
In the previous study now. In the previous study.
Oh, that is true. Sorry.
Yes, now look at the formula we are talking of. Pair, can you see this second one? Can you see? The standard deviation of the difference. Can you see? This one is the signal criterion. This is power criterion. This standard deviation of the this is the difference now.
Your pointer is not showing. No. Okay,
sorry.
I see it.
I'm coming. Let me share it. No, sorry. Can you see it?
Yes, sir.
Look at it. This is significant criterion, power criterion, standard deviation of the difference. This is the difference. The mean difference, rather. This is the mean.
I cannot see you. It's not showing here.
But somebody is
it's
seeing
still on WinPepi.
No. Okay, sorry. Can you see now?
It's coming on. Yeah, we can see now.
Yes. I say, if you look at the formula for the pair. This is standard deviation. This is the significant criterion, alpha, power criterion. This is standard deviation of the difference, and this is the mean difference. Yes, I'm now. This is the mean. This is standard deviation. So if they do a study, the difference they will tell you the mean difference and the plus or minus the standard deviation, and those are the two things you put in. So I think you put it even in your formula.
I agree. Thank you, sir.
Now, so I think that's the end of the show today. And then,
wow. Thank you.
So
sir.
all you need to do is just lay your hand on it, and the more you understand the logic, at least Dr. Udusolu, at least this one has opened you so that go and prepare before somebody hammer you in the exam.
I'll tell you,
all right. Good night, sir.
But hello, can you hear me? Can you hear me?
Yes, sir.
Can you hear me? And if you go back to that WinPepi, there's an option for use of standard deviation direct.
Okay.
There's a place.
Oh wow. Okay, let's see.
Yes. Standard deviation, yes. Is it
so
or within subject mean square in ANOVA, or standard deviation and B and correlation coefficient? But this one you have to use it together with correlation coefficient.
Okay. Okay.
And try to correlate the two group you are, the before and after is the same people. Before and after.
Yes.
So the correlation, you can use the standard deviation of A, of one of them, and B and coefficient. Can you see now? And correlation coefficient.
Okay. It's clear.
So standard deviation of A and standard deviation of B here, then correlation coefficient. If you put it, it will give you. But if you look at it, this first one is better. It's simpler. So.
Okay. Thank you.
Yeah. Okay, I think we can just stop here.
Thank you very much, sir.
All right. Thank you, sir. Good night, sir.
Yes, sir.
I hope we are expecting the videos.
Sir, me, I've been highly distracted, so I will still be calling you to ask questions.
They want the video of yesterday and the one of today.
I sent yesterday, so now. Everybody.
Okay, I have not checked.
Stop it.
I have not checked. Okay, thank you.
Thank you.